Hello everyone and welcome to today's masterclass Supercharged Node.js Advanced Performance Tuning Strategies for Enterprise Apps. Welcome to you. My name is Kamal Asawara and I am thrilled to see you so many of joining from tech community today. Thank you. So let's start with a brutal truth. Most of us or most teams choose Node.js because of developer velocity and event-driven asynchronous nature. And fast to build, fast to ship. But when your application start to scale up from 1,000 to million user base and your system getting hit 1,000 requests per second, then your system start to break down. You see CPU hikes to 100%, memory leakages, your database connections are blocked. So today we are going to discuss on that how to fine tune your application. We will just pass the general advice of scale up your system horizontally, and we will look into Node.js, what is actually happening under the hood. So at the end of this webinar, you will have a clear blueprint to actionable item that you can squeeze out maximum from your existing Node.js infrastructure. So let's start. So the problem statement is CPU, memory, or input output. So those start to create problem for you when your application have to handle the concurrency 1,000 requests per second or more than that. The event loop, which everyone knows, but we will look a different aspect of that event loop today. So all what we know that event loop is like a single threaded, Node.js is single threaded, but that is not completely true. Yes, JavaScript is single threaded, but behind the scene, who is doing all this? libuv library, a C++ library. So the library having 4 thread instead of the 1 thread. So that is not completely true. And what you can do, so instead of putting everything on single threaded event loop, you can put some of your workload on the worker thread. So your PDF generation, image generation, and any CPU intensive tasks you should handle to a worker thread. So this picture clearly shows what, so normal asynchronous request, non-blocking request. So for that, your event loop is good. But apart from that, heavy CPU intensive work, you should hand it over to a worker thread. We will see example at the end of this webinar. Okay, libuv, let's discuss in more detail. So there is a environment variable UV thread pool size. So as I mentioned, it is by default set to 4. So instead of just 1 queue, you have 4 queues. But those 4 queues are also not enough to handle 1,000 requests per second. So you can increase this to 64 or to 128. Maximum possible value is 1024, but that is not advisable because these numbers are equal to your logical core. If you set it to a big number, you will again get a hit on the performance due to CPU context switching. So set it to 64, 124 accordingly. Okay, the next thing, V8 memory. So that is coming from V8 engine, the powerhouse which is running Google Chrome, and that is also behind your Node.js application. So V8 memory management provide a like very fantastic feature of cache. So you should use that feature for your performance tuning. So that is hidden class stability. So if you're going to define your object, initialize your object always in the same manner, in the same sequence, properties are defined when you are using the cache. If instead of deleting any property, you are set it to undefined, then also you are using the cache. So keep that in mind. I will show this also as an example, and we will see the comparison, how much benefit you will get. Okay, next thing is JSON streaming. So if your application is processing a very big JSON, you should start using a package like a streaming JSON. So it actually break down your big JSON into chunks and then process it. So let's see what benefit we will get. So in this chart, you can see memory footprint. So normal JSON.parse or read file async. So you are reading file from the system. So the big memory impact. But the second thing, stream JSON, it because it works in a chunks, so it will have a small memory footprint. And time to first data, because a small data will be processed quickly, then definitely stream JSON will provide you that data first. And the last thing, crash, because you are not putting much load on the memory, then stream JSON have no risk to memory crash. But in the normal scenario, if you're putting a big JSON into memory, because it is going to process in the memory, your system can crash. So this is the one point you should consider. Let's move to the next point. Yeah. So leak detection. Memory leakage is happening, but how to detect that, what and where it is happening? So there are two methods, node inspector, but that is not advisable for application running in the production. The second thing, V8 engine also provide this method, write heap snapshot. So you should use this. So it will create a snapshot for you, and you will see there are two columns, actual memory, what should be consumed, but what it is actually consuming. And if you see a big difference, that line is where your memory leakage is happening. So you should use that. Yeah. And this flag, the second thing we can see here, max old space size. So this flag, you should set it to 70% of your total pod size. So if your pod size is 1 GB, you should set it to 700 MB around. Because if you not set it, so your pod will be killed silently and it will not leave any trace for you also, because there will be no memory left. Yeah. Let's discuss on the microservice level, what you can achieve and what other options apart from Express. Express is good for most of the scenario, but if your APIs are JSON heavy, then you should consider using the Fastify. So Fastify actually faster, like it will provide you 2 to 3 times throughput compared to Express. So we will see a chart here. Yeah. So you can see a chart here. Express.js 12K requests per second. Nest.js again 11K requests per second. But Fastify 34 requests per second. 34K requests per second. So that is nearly 3 times what is Express is giving you. So that is the test cases run on the 4-core CPU, 8 GB RAM. So this is definitely you should consider if you are using lots of JSON, then this is should be your choice. But your application is slow due to the database connection, so you don't need to change your framework. Yeah. And the last thing, because how we will act. So if you have something, some data to work upon, so if you are logging your data, what, when, what is failing, and if you have a stack trace, then you can go to that point and fix the issue. So monitoring tool should be configured to get your stack traces. So that is the thing. Yeah. And as I mentioned, I will show you some examples also. So here we can see first example is a worker thread example. So worker threads are actually introduced in Node 10 version, but a lot of people not using that. But as I mentioned, if you are doing CPU intensive work, you should hand it over to a new worker thread, and worker thread can be initialized like this. And it will keep your main thread free. So this is the one thing. Yeah. Thread full size also we discuss. So you can define it as a very first line of your code, but the ideal point of definition should be in your environment variable. But if it is related to only one script, you can define it on very first line to increase your thread pool size, and it will give you 64 queues to process your request. Yeah. So we discussed the V8 engine cache mechanism. So as you can see here, the username and age properties are used differently in different order. So it will not going to use cache. If you are always using it in the same order, so let's see a good example. Yeah. Because we are always going to use this create user good function. So it will always define those property in sequence, and that will make a significant effect on your memory management. So let's see example. I can run and show you this example as well. What is actually happening behind the scene. So this example will show you. Yeah. Hidden class performance. You can see how much difference it will make. Okay. So when I am setting property to undefined, it is taking something in millisecond, 8.93 millisecond. But the second thing you can see here, when I am actually deleting the property, so it is taking time into seconds. So this is the clear difference you can see. So you should assign a property to undefined, because that will also work for you instead of deleting the property. Okay. The next thing is stream JSON. As I mentioned, so if you have a big JSON, break it down using the stream JSON package. So you can see we are using a stream JSON package here to read a large JSON. We are reading that value and break it down into a chunk using this pipeline. And in the end, we are getting the record from the memory. So all data is processed, and you will get your parsed JSON at the end of this execution. And the next thing we have discussed, this is the example of your Docker file. So as we discussed, if you have 1 GB of RAM, so you should set your max hold space size flag to nearly 700 MB. So that we are setting here on the Docker level. And Fastify, I have one example of Fastify as well. If your application is JSON heavy, so why Fastify is fast? Because it has predefined structure for your JSON. So if you are going to give it more property than this, like 5 properties I have defined, but I am going to provide two more property that is coming from your database or any other data source. So it will strip out those additional property because it will always take the defined properties. So this is also helpful if you want to hide some properties. So whatever your prototype is defined with, it actually give those properties. But the main benefit is, so as we can see, 3x more JSON can be handled by Fastify. So I think this is the end of this webinar call, and I have done with all those things. Thank you for your participate. Thank you.